everyone, we are in another video of statistical analysis where we are looking at bivariate data analysis, which is the MS4 topic. And in this video, we are looking at the line of best fit. So the line of best fit is essentially a line through a scatter plot that is a representation of all the different points on that scatter plot. So you'll have multiple points, but the line of best fit is just the one line representing all of those points. So if we have a look at the blue box, we'll get a definition for it. So the line of best fit is a straight line that approximates a linear association between points. And to figure out the line of best fit, we can use the gradient intercept formula, which is y equals mx plus c, or you may have seen it as y equals mx plus b. The value m is just the gradient, and b and c both equal the y-intercept, just interchangeable values for that. B and c are both the same though. And the objective is to fit a line to the scatter plot so that the line is as close to as many points as possible. So by doing this, you would normally draw the line down the middle of all the points, because that will give you the best chance of being as close to as many points as possible. You don't have to have any points lying on the line. You can, but it doesn't matter. But the most important thing, the thing that does matter, is having an equal number of data points above and below the line. Now, this won't always be possible. Sometimes you might have 8 above and 9 below, but you want to try and get as many as, like, as close to it as you possibly can. So that would be okay, but having maybe 5 and 12, that would be bad. You want to try and get to an equal number as possible. So if we have a look at this example in the corner, your first step to getting the line of best fit would be to draw a line down the middle of all the points. So if I was to draw a line down here, let's say about there, and then my second step would be to count up the points above and count up the points below. So above, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 above, and 1, 2, 3, 4, 5, 6, 7, 8, 9 below. And then I have 2 points, 1 and 2, lying on the line. So it doesn't matter if you have them lying on the line or not, but your main aim is to have an equal number, 9 and 9 above and below. So let's have a look at the next slide. If my computer is going to go. Oh, we went too far. Here we go. So when we have the least squares line of best fit, so it is another type line of best fit, except instead of getting the line of best fit just by drawing it on, this time we will have formulas to calculate the gradient intercept form y equals mx plus c or b. So the least squares line of best fit is a line of best fit that minimizes the sum of the squares of the vertical distances. So what will happen with the least squares line of best fit is you'll calculate with your calculator lots of different values, which we'll have a look in the next slide. And by doing this, you can sub those values into formulas, and these formulas will solve for the gradient. And also your second formula that you will solve for will be for the y-intercept. And once you have solved for these two, you can then sub those two into the y equals mx plus c to get the line of best fit. So it seems very confusing, but we will go through it now and have a look at what this all means. I don't know why my computer, here we go. So, here we have all the different values. So you will have the gradient intercept form, which is this, and that is our final outcome. That's what we want to end up with. We want to end up with a formula with values for y equals mx plus c. So we need to find what m equals, and we need to find what c equals. And there's two different ways to do this. We have m equals Pearson's correlation coefficient times the standard deviation of y over the standard deviation of x. And we have our second formula for c, or the y-intercept, which is the mean of y minus m times the mean of x. So we need to do this one first and then this one second, because our m value is in our second equation. So you can't calculate the second equation without first having the m value to sub in there. So when I'm doing a question for the least squares line of best fit, on my calculator, I will put all my values in, and then I will write out each thing. So sy, r, x, y, and I also need m. And I will calculate what each of these equal. And once I've found what each of these equal, then I'll sub them into the first equation. Then I will do the second equation. And then once I have found what my c and my m equal, I can then put them into this equation up the top to get the equation of the line of best fit for the least squares line. So let's have a look at the calculations that are necessary to find these values. My computer, please work. It's a bit slow. Oh. Here we go. So as you can see up the top, here we have the two different equations to get m and c. And we have here all the different values that we need to find. So firstly, what you have is you'll be given a table of values. And once you're given these tables of values, you need to put all the values into the calculator. So I'm just going to do an example for two variables, x and y, and I'm going to just do 2, 3, 4, and 5. And let's just say 7, 9, 11, and 13. And so our first one is we are going to put all those values, the table of values that I just drew up, into the calculator. So if you've done this before, I think we did it in the previous video, your first step is to press mode setup, which is the blue button right there, press mode setup, and it will come up with different options, and you want to press 2 to go into stat mode. Then you need to press 2 again to go into A plus BX, and it'll come up with two columns like that. We have a X column and a Y column, and you can go in and put in the table for X and Y. So our X value equals 2, 3, 4, and 5, and then you go across and do the same for the Y, 7, 9, 11, and 13. And when you put them into the table, the two columns, you need to make sure that 2 and 7 are corresponded together, 3 and 9 are corresponded together so that the ordered pairs stay together. Otherwise, it will change your values. So once you do that, you press AC, and there should end up with a little 0 down the bottom, because that demonstrates that we are now in stat mode, and any answers that we will get will be according to the table of values that we just put in. So our next step would be to find all of these values. So I'm going to start with SY. We'll just go across, and we need to press Shift 1. So press Shift 1, and it will come up with all these different options. We need to press 4 to get into there, and then all the options will come up. And so we want to find SY, so we press 7 equals, and it will come up with a value of 2.58. Then you can press AC, press Shift 1 again, press 4 again, and press, let's press 4 again to get SX. And then you will get a value of 1.29. Once we do that, let's try again, and let's do it for the standard, the mean of X and the mean of Y. So press Shift 1, press 4, press 2 for X, and X will equal 3.5, and press Shift 1 for 5 equals 10 for the mean of Y. Now let's find our Pearson's correlation coefficient, which is R. So we press Shift 1. This time we're different. We're pressing 5 to go into reg. Press 3, press equals, and you'll get 1. So once you get all of these values, you can then sub them into the formula. So the first one we want to do is M. You need to find M first, and then you need to find the y-intercept, because as I explained before, you need to have the M in your second equation. So obviously you need to calculate it first for it to then be in your second equation. So M equals 1 times SY, which is 2.58, over 1.29. And when we calculate that, so you can just put it in your calculator. And when you put it in your calculator, you'll get a value of 2. And then we can do C equals 10 minus 2 times 3.5. And then you'll get a value of 3. And then we can then write that into our equation, y equals 2x plus 3. And that's our y equals mx plus c formula. So that's how you use all of the different values to get the least squares line of best fit. And on our next slide is something very important. Once you have found all the values, you need to clear the memory. And that's by pressing Shift 9, and it will come up with these 3 options. If you press option 3, equals, and then AC, your calculator will go back to normal, and there will be no 0 in the corner, which means you are not in statistical mode anymore, and any answers you get will be accurate. If you don't clear your memory, any answers you get will be based off the values that you had put into your calculator. So let's have a look at the next slide. Here's an example for this one. The heights X and masses Y of 9 people have been recorded, and the values of the following statistics determined. So here they have already given us the values, so we don't have to calculate them. We just need to remember our formulas. So calculate the gradient of the least squares line of best fit. So I'm going to do A down here, and if you remember, our gradient is our M, and our M equals R times SY over SX. So now we can sub the values they have given us into that equation. So we can go M equals R, which is 0.9743, times SY, which is 6.6833, over SX, which is 8.6681. And when you put that into your calculator, you can get 0.9743 times 6.6833 and 8.6681. You will get a gradient of 0.75. So I just rounded it up there, but there was more values after that. Now let's do question B. Calculate the y-intercept, and if you remember, the y-intercept formula was C equals the mean of y minus m times the mean of x. And if we do that, we have C equals the mean of y, which is 67, minus 0.75 times the mean of x, which is 176.5556, which equals, now put that into your calculator, you should get a value of negative 65.4167. And then for C, write the equation of the least squares line of best fit. We know is y equals mx plus c. So then we can sub our m value and our c value. Y equals 0.75x plus, but we have a minus there, so it'd be a minus 65.4167. So in this example that we have just done, they already gave us all the values that we needed, but on the other side, we went through how to calculate those values in case the question asked you to calculate them. And that's how you get the least squares line of best fit, using the two formulas and the line of best fit by drawing a line down the middle and having an equal number above and below.